With me is Alex Schulman from Saccade Vision. And Alex is going to talk about selective and locally optimized feature-based 3D scanning. Exciting topic.
Thank you very much. Thank you, Anna, and thank you very much for the opportunity to present. Saccade Vision is a startup company that is founded, as I said before, in 2020. We have recently launched our first product and started already deployment of our solution in the manufacturing floor. We develop a 3D quality inspection solution for precise manufacturing, fast and robust solution that can be deployed in minutes by factory technician. We focus on automated assembly and discrete manufacturing of precise parts such as post-CNC, metal stamping, metal forming, plastic injection, anything that is related to precise manufacturing. So what's the problem? Today, quality inspection is quite expensive, and actually inspection and faults prevention in precise manufacturing may cost up to 9% of the company's revenues. And to a large extent, it is because existing machine vision solutions often require application-specific development, complex integration, and in general, lots of efforts to get reliable results. Those indirect costs are typically 4 to 5 times higher than the direct cost of components, of hardware and software components. We want to make the quality inspection more affordable with the most flexible machine vision solution for the three-dimensional inspection that can be instantly deployed by factory technicians. We're actually very happy that in less than 2 years we were recognized by professional community and started the deployment of our solution. We also work on data analytics software that uses our inspection solutions for process and machine health analytics and for design for manufacturing. Our sensor is based on a flexible laser scanning with a MEMS mirror, similar to, in some sense, to the automotive LiDAR. However, unlike LiDAR, our MEMS is fully controllable on both axes. It's not resonance scanning. And using that and using our smart software, we can optimize data acquisition separately on each region of the inspected parts. We call this a feature-based camera. For example, here, by analyzing of the drawing of the inspected part, we decide what is the best direction of scanning, best illumination, required scanning density, etc. And we do it separately for each feature. This results in an optimized point cloud with variable density. Today, system integrators often need to optimize the direction of scanning. This is not something that we invented. And precise and expensive motion systems are used, a robot in this case. Scanning using the MEMS mirror, as on the right side with Saccade Vision, allows cost-effective solution and can be also significantly improve the takt time, the speed of scanning. So let's see why the direction of scanning is important. You can see this example of a very fine 3D printing resolution target. When the direction of scanning is fixed, some walls are imaged reasonably well. However, other perpendicular walls have some undersampling issues and also have poor visibility in some cases. However, with our optimized scanning per region, we can scan it with the best possible quality per region. This approach helps us achieving selective super resolution in 3D. You can see it on the right side. We can get higher quality 3D image on twice larger field of view, is in this case when we compare with the laser profilometer. The system can use prior knowledge about the manufactured part, for example, a CAD model, analyze the CAD model, focus on regions of interest with higher resolution and best possible quality. And we are now developing a software that will be able to fully automate the process, taking the CAD model and transforming that into the inspection solution. Another significant advantage of regional optimization is the ability to deal with highly reflective objects. And those of you who deal with this type of imaging will probably appreciate the complexity of this application. As you may see, if you acquire the full image with the same direction and same parameters, you will result in a lot of dropout points. However, what we do here, we optimize the scanning parameters, the direction of scanning cameras that are being used for triangulation based on the location. And this is what allows us to almost eliminate strong reflections. One of the use cases we focus on is the measurement of critical dimensions of precise metal and plastic parts. The system's deployed already in multiple customers, and we show great improvement on all KPIs. We were able to measure some critical dimensions that were not available for CMM or manual measurements. We increased dramatically the quality control capacity, the amount of parts that were inspected, and we solved with a single solution for completely different applications. Another use case is three-dimensional inspection in mechanical assembly lines. We have our system installed in the automated assembly line and collecting thousands of data points per shift. So far, we inspected well over 1 million units with this system, almost 1 year, 24/7, without even a single stop. Recently, we announced a partnership with an Italian robotic software company to offer an integrated inspection system for metalworking machines. In some cases, the sensor can be mounted on the robot and perform precise scanning from different visibility points. In other cases, the same robot is being used to load, unload parts to and from the metalworking machine, and the same robot can be used with the inspection system. So imagine an inspection system integrated nearby the CNC machine, and every part is being scanned right after processing. And we will be happy, of course, if you have questions. We are here in the startup world. We will be happy to host you, to do a live demo with our system. And thank you very much again for the opportunity to present.
Vision presenting selective and locally optimized feature-based 3D scanning. Questions? One question, Sigrid?
Who are your customers and how big is the market for that solution?
So the end customers are either contract manufacturers, such as the names that I'm saying is not necessarily the names who are we working with, but Jabil, Flex, Foxconn, these are customers, or end customers who manufacture their own product. However, our immediate partners, immediate customers are system integrators. So we basically, the idea is we want to be scalable as a startup. This is probably every startup will want that. And our idea is that we want to focus on a generic solution, and we want to leave the application-specific development for system integrators. And this is actually the work with these software robotic companies was the first one. We were able to sell to a very large German industrial corporation through that integrator. So this is a validation of the business model. And regarding the market, the existing market for laser profilers and 3D sensor quality inspection is probably around $500 million. But we expect this to grow significantly as we enable some additional sectors that are not covered today.
Thank you. And one final question from the chat. What is your estimate on possible cost reduction using your system compared to the ones existing in the market?
So we did an ROI modeling for an average CNC machine shop with 50 CNC machines. And to make it short, we estimate the annual ROI. If we go into the leasing model plus software, we estimate annual ROI as 2.5x on the investment.
Thank you. Alex Suhlmann from Saccade Vision, selective and locally optimized future-based 3D scanning. Perfect.